Right, so chord of contact to the ellipse. So what's happening here is pick a external point, so we're going to call it T. We're going to give it the coordinates x0 and y0. Draw tangent to it, so P and P prime on the diagram there, x1, x1, y1, x2, y2 respectively, and then we draw the line through those 2 points to make the chord of contact with those 2 tangents. There. So with that, the equation of that chord of contact from an external point T is given by that, which is very similar to your tangent to an ellipse formula. Okay, so x naught x, 1 over a squared, 1 naught y over b squared is 1. They're all in your notes. Okay, so the tangent at T, okay, has equation of x1 x over a squared plus y1 y over b squared is 1. So that's our tangent formula. So it shows the chord of contact is very similar in terms of well, exactly the same really when you substitute the point in. That at P prime, we've got x2 x over a squared plus y2 y over b squared is 1. Okay, and all it is since the point T is on both tangents above, then that point must satisfy both those tangents there. Okay? It must satisfy both the equation above. We could do a more detailed proof, but really it's just applying common sense there. Alright, so therefore x naught x over a squared plus y naught y over b squared is 1. Right, so really you just have to substitute that external point into the tangent formula. Right, that's all you need to do. Alright, so from a point T, 14, root 5, 2 tangents drawn to touch the ellipse. Find the equation or the chord of contact, and then find the coordinate of the point of contact. Right, so we've got x squared, got to divide everything by 36 to get the tangent by itself. The coefficient of 1 on the right hand side. Right, so we're just working off that. Okay, so the formula that we just covered for x naught x over a squared plus y naught y over b squared is 1 will be the equation of the chord of contact. Okay, and then the x naught and y naught is the external point. So 14 x on 36 plus root 5y on minus 1. On 36 is 7 on 18. put it over common denominator. Just to make when I multiply by non-root 5, it just makes it a bit more simple. So it's going to be 18 minus 7x on 2 root 5. Right, so the rest of the question you'd say, hence find the coordinates. Okay, I'm not going to go do that one because I want to cover other things. But really, you've got your line, you've got your equation of your ellipse, you're just substituting and solving simultaneously to get your 2 points of intersection there. Okay, so I will leave it at that for this particular question. Okay, but to get the idea of what you need to do here. Right, so from point T, x naught, y naught, two tangents are drawn to touch the ellipse. X squared over 16 plus y squared over 4 equals 1. Okay, so remember A is greater than B, so we've got the foci on the horizontal axis. Okay, so the chord of contact meets the axes at M and N, so if the midpoint of that lies on the inner circle we send at the origin, we need to find the locus of T. Okay, so when you're looking for a locus question, sketch is always handy. Right, so we've got some external point, I'm going to work it over here somewhere. Two tangents are drawn. Okay, not necessarily meeting on the y-axis, but that's how it works. The chord of contact makes the axes at M and N. If the midpoint of N lies on the unit circle we set at the origin, okay, so we've got some midpoint here, that's on the unit circle there, radius 1, we need to find the locus of T. Right, how that external point moves to match the condition that it's the midpoint for the intercepts of the axes. Alright, so we've got x naught x over a squared plus 9 naught y over b squared is 1. Right, that's the equation called a contact. So x naught x over 16 plus y naught y over 4 is 1. So the external point is x naught y naught. Okay, and that's the equation of the chord with those points. Alright, so we need to find the intercepts of the axes. Okay, so we just found the equation of that chord there using the formula. Intercepts. So M, we know that the y value is 0. for the intercepts of the x-axis. So x naught x on 16 is 1. So the x value is going to be 16 on x naught. And the n, we'll cut the y-axis, so we set the opposite letter equals 0. Okay, and similarly, y is going to be 4 on y naught. Right, so we need the midpoint. Okay, so we've got the x and y value from that. Okay, so therefore midpoint. Okay, it's halfway between the origin and the intercepts. Okay, so the x value is going to be half of 16 on x naught. So it'll be 8 on x naught. And the midpoint is going to be halfway between the origin and the y-intercept. Okay, so that point is on the unit circle. Okay, so we've got that point here, which is on the unit circle. So I'm going to substitute that equation in for the unit circle at the centre of the origin. I'm going to put that into x squared plus y squared is 1. But I'm going to solve for y. Yep, and then I'm going to flip the fraction over and bring the 4 up. And because y naught and x naught is the point of t, and we're following the locus, and now we're tracing a path, so I'm changing now my y naught and x naught to y's and x's. Okay. Y is going to be 4 x naught squared over x naught, that's right. So no, change to y naughts and x naughts. So 4x over x squared take away 64. But there are a couple conditions because we can't have x naught as 0 because we're dividing by 0 here. Okay, so therefore overall we can't have x equals 0 here, and also we can't have the denominator of 0 here, right? So we can't have x equals plus or minus 8, okay? So such that x cannot equal 0 plus or minus 8. Otherwise we get the denominator of 0 there when we substitute 8 or negative 8, and then from the midpoint I can't have 0 either. Okay, so we're going to have some breaks in the actual graph, which looks something like something like that. Okay. I'm not asking you to sketch that. Right. So it's really just algebra. Putting the locker question.